Good morning, student. Today I am going to start the topic that is valence bond theory, and the subtopic is that is some important examples which is related to the valence bond theory. In previous video I have discussed the example related to sp3 hybridization and dsp2 hybridization, but today I am going to discuss the bonding in coordination compound, that is according to valence bond theory. First example is that is CO. First example is CO F6 3 minus. First of all, you are required to write the IUPAC name of this particular compound. You are required to calculate the oxidation state of central metal. So suppose the oxidation state of central metal is considered as X, and what is the oxidation state of one fluoride ions? That is, it contains one negative charge, so it has -1 charge. So X plus -6 is equal to -3. So X minus 6 is equal to -3. So X is equal to -3 plus 6, then we get +3. So the oxidation state of this particular cobalt is +3. Okay, so you are required to write the name of this particular compound. So first of all, you are required to write the name of the ligands. How many ligands? 6 ligands. And in case of fluoride, in IUPAC nomenclature, fluoride is written as fluorido. Okay, how many fluoride? Ion 6. So hexa fluorido, it contains negative charge, so you are required to write the name of central metal with adding 8. Hexa fluorido cobaltate. It contains 3 positive charge, means oxidation state is 3. So you are required to write in the small bracket, and it is an ion, so you are required to write the name ion. So the correct name of this particular compound is hexafluorido cobaltate third ion. Okay, so I am going to explain bonding in this particular compound according to valence bond theory. First of all, what is the atomic number of cobalt? Atomic number Z is equal to 27. So you are required to write the electronic configuration in terms of outer S and outer D. How many electron in D? So CO Z is equal to 27. It is written as 3D7,4S2. This is the outer electronic configuration of cobalt, outer subshell or outer shell electronic configuration of this particular cobalt. It contains 3 positive charge. So in case of CO 3 plus, the configuration is written as 3D6,4S0, and this is 4P0. So you are required to draw the orbital picture diagram. This is 3D. It contains 5 orbital, 1, 2, 3 and 5. S, it contains only 1 orbitals, and P, it contains 3 orbitals, that is Px, Py and Pz. How many electrons? That is 6 electrons. So you are required to write number of electrons in each orbitals according to Hund's rule. This is 6 electrons, and in this case the next orbital is d orbitals, 1, 2, 3 and 5. This is 3D, this is 3D, this is 4s, this is 4p, and this is 4d. So how many ligands present? That is 6 ligand. 6 ligands present. 6 ligand present. So how many orbitals required? That is 6 orbitals. So 1, 2, 3, 4, 5, 6. So these 6 orbitals hybridize and form a set of orbitals having equivalent energy. So these orbitals, this is 1, 2, 3, 4, 5, 6. These orbitals hybridize and form orbitals, 6 orbitals having 1, 2, 3, 4, 5, 1, 2, 3, 4, 5, and this is 6. So this is 4s, this is s, this is p, and this is d. So the hybridization is sp3d2. So the hybridization is sp3d2. Okay, and rest of the orbitals are present in this way. And in this case, the 3d orbitals can be represented as in this way: 2, 3, and 5. 3rd, 4th, 5th, and this is 6th. So in this particular hybridized orbitals, how many ligands? 6 ligands. So F minus can form coordinate bond with this particular orbitals, and second F minus again form coordinate bond, and third form coordinate bond, fourth it also form coordinate bond, and this is fifth form coordinate bond, and this is sixth form coordinate bond. Okay, so how many coordinate bond form? 6 coordinate bond, and the hybridization is sp3d2. So how many unpaired electrons? That is n is equal to 4. So it form spin free complexes, and it is a outer orbital complexes, because outer orbitals, that is s, p, and d, are involved in bonding. This is called outer orbital complex. It is spin free, it is paramagnetic because it has unpaired electrons. It is paramagnetic. So it forms outer orbital complexes. It is spin free because there is a 4 electron which is not paired, and it forms paramagnetic because number of electrons, unpaired electrons, is 4. So in this way we can explain the Vbt theory by taking the example, that is COF6 3-. So the hybridization is sp3d2. And next, what is the geometry, what is the shape of this particular compound? How we can draw the shape of this particular compound or geometry of this particular compound? Okay, so in sp3d2 the geometry is octahedral, or it is also known as square bipyramidal. This is central atom is cobalt, this is F minus, F minus, F minus, F minus, F minus, and F minus. How many charges present? This is 3+ charge. So in this way we can write the geometry, that is known as octahedral geometry or octahedral shape. So this type of geometry obtained in the case of COF6 3-. Okay, so next example I am going to explain. Next example, the next example is CONS3 whole 6 3+. CONS3 whole 6 and 3+. First of all, you are required to calculate the oxidation state of cobalt. X plus 0 is equal to +3, because ammonia is a neutral molecule, so its oxidation number is 0. So X is equal to +3. So the oxidation state is cobalt is +3. Then you are required to write the name of this particular compound. This is tetraamine cobalt, because it contains positive charge. Cobalt third, because oxidation number is 3, cobalt third ion. So this is the correct IUPAC name of this particular compound. Okay, what is the atomic number of cobalt? I have already explained. Cobalt, the atomic number Z is equal to 27. So you are required to write the electronic configuration of cobalt. This is 3d7, outer electronic configuration 4s2. In case of cobalt 3 plus, the configuration is 3d6 4s0, and this is 4p and this is 4d. Okay, so this is 4p, this is 4s, and this is 4d. Then you are required to draw the orbital picture diagram. This is 3d 1, 2, 3 and 5. It contains 5 orbitals. In case of 4s, it contains only 1 orbitals. In case of 4p, it contains only 3 orbitals. Okay, so how many electrons? 6. 1, 2, 3, 4, 5 and 6. Okay, ammonia it is a ligand which can pair the electrons in a particular orbitals. So it has a tendency to pair the electrons in a particular orbitals because it is a type of ligand which act this type of action or this type of phenomena. Okay, so what will happen when electron get paired in a particular orbitals? 1, 2, 3, 5. So all electron get paired. So this type of, we can represent this in this way. This is 4s and this is 4p. It is not required to write 4d. Okay, so how many orbitals required? In case of NH36, it is required to write hexaamine, not 4, hexaamine, because it requires 6 orbitals, 1, 2, 3, 4, 5, 6. So these orbitals can be hybridized and form orbitals of equivalent energy 1, 2, 3, 4, 5 and 6. So hybrid orbitals are, this is D2sp3. So this type of hybridization is known as D2sp3 because inner d orbitals involved. Then this is 3d, this is 4p and this 4s and this is 4p. So in this way, how many ligands? 6 ligands present. So 6 ligand can donate the electron pair to this particular orbitals. Okay, so 6 D2sp3 hybrid orbitals form after the hybridization. And how bonding occur, bond formation, how we can represent the bond formation? We can draw this particular orbitals in this way again, 1, 2, 3, 4, 5 and 6. Okay, so how many ammonia? Neutral ligands 6. NH3, this is second NH3, this is third NH3, this is 4 NH3, this is 5th NH3 and this is 6th NH3. Each contain a lone pair of electrons. Okay, so it form coordinate bond by donating the electron pair. Second ammonia molecule also form coordinate bond, and third ammonia donate electron pair to this particular orbitals, and fourth ammonia donate electron to this particular orbitals, and fifth ammonia, and this is 6th. So the hybridization is D2sp3 because inner d orbital, this is D2 this is S and this is P3, because in this case 2 orbitals involved. In S only 1 orbitals involved. In P3 means Px, Py and Pz. So the hybridization is D2sp3 hybridization. So in this way we can draw the orbital picture diagram and we can show the bonding in CO NH3 3 plus on the basis of valence bond theory. Okay, so how many unpaired electrons? N is equal to 0. It form outer, not outer, inner orbital complexes. Inner orbital complex, it is spin paired, it is spin paired. Low spin complexes, low spin complex, because magnetic moment is equal to 0. So number of unpaired electron is equal to 0. It form inner orbitals complexes because 3d orbitals involved in hybridization. Spin paired because all electrons are paired. Low spin because there is no unpaired electron, so magnetic moment is equal to 0, so it is known as spin, low spin complex. It is diamagnetic because it has no unpaired electrons. Diamagnetic. It is a diamagnetic because it has no unpaired electrons. Okay, so this type of hybridization can be we can represent in this way. The hybridization of CO NH3 containing 3 positive charge, it form inner orbital complexes. Then next is how we can draw the geometry or shape of this particular compound. In D2sp3 the geometry is octahedral. Geometry is octahedral. Okay, it is also known as square bipyramidal. The geometry is octahedral. Central atom is cobalt, which contain 3 positive charge. And how many ligands present? How many ligands? That is 6 ligand. This is ammonia 1, this is 2, NH3, this is 3, this is 4, this is 5, and this is 6 ammonia. Okay, so in this way we can draw the particular structure, a particular geometry of this particular complex compound. This is known as octahedral. It is also known as square bipyramidal. Square bipyramidal. Okay, so it is also known as octahedral, or it is also known as square bipyramidal. Okay, so valence bond theory is related to number of electrons present in valence shell, and the shape or geometry depends on the number of ligands present and hybridizations and number of ligands present inside the coordination sphere. Okay, next point is what are the limitations of Vbt theory, valence bond theory. It is very important. What are the limitation, or it is also known as what are the drawback? What are the drawback of Vbt theory? It is also limitations or drawback or weakness. It is also known as weakness. What are the weakness of Vbt theory? That is valence bond theory. So limitation is also known as drawback and limitation is also known as weakness. So what is the limitation of Vbt, what is the drawback of Vbt, and what is the weakness of Vbt? In this way, in examination question is related to these types of statements. Okay, so what are the limitations of Vbt? First limitation is Vbt cannot distinguish between weak ligand and strong ligand. Weak ligand and strong ligand. So BBT theory cannot distinguish or cannot explain weak ligand and strong ligand. This is the first limitation, and second limitation is that it cannot explain hybridization. Cannot explain hybridization. Why compound form? It cannot explain why compound show sp3 hybridization or dsp2 hybridization. Okay, in coordination number 4. So first point, BBT cannot distinguish between weak field ligand and strong field ligand, and second point, it cannot explain why compounds show sp3 why compounds, so that it means why central metal in a particular compound show sp3 hybridization or dsp2 hybridization having coordination number 4. Okay, and the third point, third limitation is it do not explain the quantitative it do not explain the quantitative estimation of magnetic property. It means it only say about it is a paramagnetic, it is diamagnetic, but it do not explain what is the value of magnetic moment. Okay, quantitative means there is some amount or some value, some formula which we can calculate the magnetic moment. So first is valence bond theory cannot distinguish between weak field ligand and strong field ligand. Second point, it cannot explain why compound central metal form in a particular compound so sp3 or dsp2 hybridization having coordination number 4. And next point, it do not explain the quantitative estimation of magnetic property, magnetic data, that is it is unable to calculate the value of mu. Okay, so these are the points which is related to these are the point which is related to the limitation of valence bond theory. I am going to explain one more time. Valence bond theory cannot distinguish between weak field ligand and strong field ligand. It cannot explain why central metal in a particular compound so sp3 or dsp2 hybridization having coordination number 4. It does not explain the quantitative estimation or quantitative measurement of magnetic property, that is it is unable to calculate the value of mu. So these are the points which is related to limitations, weakness or drawbacks of valence bond theory. Okay, so next theory, before I am going to start the next theory, I am going to discuss some important question which is related to the particular topic. The complex, first question which is related to MCQ question. First question is the complex that is COF6 3- is the complex COF6 3- is, first option is outer orbital and diamagnetic, outer orbital and diamagnetic. Second option is inner orbital and paramagnetic, inner orbital and paramagnetic, and third option is outer orbital and paramagnetic, outer orbital and paramagnetic, and last option is inner orbital and diamagnetic. Fourth option is inner orbital and diamagnetic. Okay, So there are four options. The complex COF6 3- is outer orbital complexes and diamantics, inner orbital complexes and paramagnetic, outer orbitals and paramagnetics, and last one is inner orbitals and diamagnetic. First of all, you are required to calculate the oxidation state of cobalt, that is +3. Okay, so the atomic number of cobalt is 27, so you are required to electronic configuration 3d7 4s2. So you are required to write the electronic configuration of CO3 plus, that is 3d6 and 4s0. Okay, so you are required to draw the orbital picture diagram. This is first orbital, second, third, fourth and fifth. How many electrons? 1 2 3 4 5 and 6. Okay, so fluoride ion is a ligand which cannot pair the electrons in a particular orbitals. So the electrons is not paired in a particular orbital. So how many unpaired electrons? That is n is equal to 4 unpaired electrons. So there is no orbitals vacant, so there is no inner orbital complex form. It form outer orbital complexes because each orbitals contain at least one electrons. This contain 2 electrons, but it contains one electron, so electron is not going to pair. Okay, so ligand is not donate the electron in particular orbitals because they contain 1 electrons. So ligand required empty orbitals. So the option is it form outer orbital complexes because 3d orbitals is not involved in this particular complex formation. It is diamagnetic. Now it is not a diamagnetic, so first option is incorrect because it contains unpaired electrons. Second, inner orbital complexes incorrect, outer orbitals because it form outer orbitals and paramagnetic. So option third is correct because it is a paramagnetic because it has 4 unpaired electrons. So in this way we can easily answer the particular question which is related to outer orbital complexes or inner orbital complexes, and it has paramagnetic or diamagnetic on the basis of Vbt theory. Okay, so this is first question which is related to valence bond theory. Next question. Which is high spin complexes? 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 First A, that is COF6 3-, COF6 3-. Option B, FeCN6, FeCN6 3-, FeCN6 4-, FeCN6 4-, and last option is D, that is none of these. None of these. Okay, which is high spin complexes. So in this case, Cn is a ligand which can pair the electron. Cn is a ligand which can pair the electron, plus F- is a ligand which cannot pair the electron. So in this case, number of electrons, number of unpaired electrons is equal to 4. So it form high spin complexes because high spin or low spin depend. High spin complex formation, high spin complex formation depends on, high spin complex formation depends on number of unpaired electrons. Number of unpaired electrons. Number of unpaired electrons. So in this question, COF6 3- contain maximum number of electrons because it has no tendency to pair the electrons, and Cn it is a ligand which has a tendency to pair the electrons. So option A is correct option. Okay, So in next video I will explain the CFT theory, next theory which is known as crystal field splitting theory, and crystal field splitting theory is a very important theory. Okay, so tomorrow I will discuss the crystal field theory. Thank you for watching the video. Thank you very much and have a nice day.